Dear students, today we are going to start new topics. That one is application of derivatives. We already studied about the derivatives. Now, application of derivative. Application of derivatives. At first, let us talk about introduction. Introduction. The application of derivative plays a very important role in the field of engineering, science, math, economics, commerce, and so on. With the help of derivatives, we can be solved the maximum profit to be made with the help of minimum investment comma similarly the increasing and decreasing tendency of the cost function, etc. Students, I think you know about these all. Here, with the help of derivatives, we can solve the maximum profit to be made with the help of minimum investment. Similarly, increasing and decreasing tendency of the cost function. So now let us discuss about increasing and decreasing function. Now increasing and decreasing function. Increasing and decreasing. The increasing and decreasing decreasing nature of the function are also used in in finding the maximum and minimum values of the function. Here we use derivative to examine the increasing and decreasing tendency of the function in an interval. Now let us discuss about one graph. Let us suppose this is x-axis and this one is y-axis. Curve. Suppose a curve is like this. Can draw here. This point is A, and maximum point we can write D. So let us draw one perpendicular from here. We can draw here perpendicular by dotted line here. Here is also, and then from this point A, B, C and D like this. We can give suppose P, Q, R and S the name. So in this figure, here the figure is continuous. This figure is continuous curve. This continuous curve represented by the given function fx is equal to, this is a function fx is equal to y, or y is equal to fx. We can write the figure is the continuous curve represented by the given function y is equal to fx. Consider the points A, B, C and D on the curve where OP is equals to, right here O, then it will be OP, and OP is equal to, we suppose this one is x1. OP is x1. Here OP from here to here, suppose this one is x1. Similarly OQ is up to here, this is x2, and similarly OR is up to here, this one is x3, and this one is up to here OS, this one is x4. So we are going to write OP is equal to x1, and then OQ is equal to x2, OR is equal to x3, similarly OS is equal to x4, and similarly we have PA is equals to, here is x1, so we say this one is in y, this y means y is equal to fx1, so we say this one is fx1. Here is fx1, this is x1, so y is equal to fx1, that one is, so PA is equal to fx1. Similarly, qb is equal to fx2. This is also y, fx2. Similarly, rc is equal to fx3 and sd is equals to fx4. Here, this one is x and this one is y. So this one is x, this one is y. So this means fx2 means y. So this is also up to here. OR is x, x3, and this one is fx3 is y. This one is fx4. This one is also y. From the figure, we see that the curve increases from A to B. Here is from A to B. Here is increasing. This curve goes up. यसरी increasing भएको छ. Then decreases from B to C. Again increases from C to D. Again goes up here from C to D. That is in the part of AB, and then in the part of BC, in the part of CD. That is in the part AB, x2 is greater than x1 gives, हेर्नुस् त, in the part of AB मा हाम्रो x2 is greater than x1. x1 सानो छ, x2 ठुलो छ. So x2 is greater than x1 लेखेका छौं हामीले, which gives fx2 is also greater than fx1. fx2 हेर्नुस् त, fx2 भनेको यो qb भन्ने लाइन यो pa भन्दा ग्रेटर छ. अनि फेरि हेरौं हामी in the part BC x3 is greater than x2. x3 भनेको यहाँदेखि यहाँसम्म OR अनि x2 भनेको OQ भन्दा OR नै ठुलो छ. So x3 greater than x2 gives, हेर्नुस् त, it implies is fx3 is less than fx2. fx3 means this one. यो चाहिँ fx2 भन्दा के छ हेर्नुस् त, स्मलर छ. त्यस्तै in the part CD, that is x4 greater than x3 implies fx4 is also greater than fx3. fx4 हेर्नुस् त, fx4 is greater than fx3. यसमा x4 is also greater than x3. Now we have the following definition. Of increasing and decreasing function. Now about increasing function. Increasing function हामीले हेर्नुस् त, increase र decrease दुवै हेर्यौं. यहाँ हामीले के देख्यौं A देखि B सम्म इन्क्रिज, B देखि C सम्म डिक्रिज, C देखि D सम्म फेरि इन्क्रिज। हियर यो हेर्नुस् त यहाँ हामीले यसरी स्लोप हामीले यसरी चाहिँ यो टेन्जेन्टहरु ड्रा गर्न सक्छौं। We can draw like this. अब इन्क्रिजिङ एन्ड डिक्रिजिङ फंक्सन को बारेमा चर्चा गरौं। A function y is equals to fx is said to be increasing in the interval AB if for every x1 comma x2 belongs to AB, that is x2 greater than x1 implies fx2 is also greater than fx1, which shows x increase y or fx भन्छ हामी y लाई, y or fx also increase। हेर्नुस् त यो बढ्दाखेरि यो ठुलो हुँदाखेरि यो पनि के हुन्छ ठुलो हुन्छ इन्क्रिज हुन्छ बढ्छ भने हामीले हेर्यौं। thus y is equal to fx is an increasing function if dy by dx is equals to यो डेरिभेटिभ अफ x with respect to y हो, यो डेरिभेटिभ अफ y with respect to x हो, यो is equals to यो फर्स्ट डेरिभेटिभलाई हामी f dash x पनि भन्छौं, which is greater than 0. Now about decreasing function. Decreasing function. What is mean by decreasing function? Okay, this is the definition of function y is equals to fx is said to be decreasing function, said to be decreasing in the interval AB if for every x1 comma x2 belongs to AB, that is x2 is greater than x1, which implies fx2 is less than fx1. पक्कै तपाईहरुलाई यो राम्रोसँग थाहा छ x2 is greater than हामीले एक कुरा गरिराखेका छौं। हेर्नुस् है यसैलाई हामीले डेफिनेसनको रूपमा राखिराखेका छौं। x2 यो x2 is greater than x1 यो भन्दा यो सानो छ अथवा x2 ठूलो छ त्यतिबेर यो फंक्सन चाहिँ हेर्नुस् त यो fx1 चाहिँ fx2 भन्दा के छ स्मलर छ। सो f यसले चाहिँ x2 is greater than x1 x2 ठूलो भएको अवस्थामा हेर्नुस् है यो fx2 here we have to look very carefully. Here is x1 x2, this one is decreasing, so we have to look from here to here. So this one is from here to here, this we suppose x2, and then from here to here OQ is x1, so x2 is greater than x1, and then this one is fx1 and then this one is fx2. first लाई x1 second लाई x2 सपोज गरेको भएर हाम्रो यहाँ यस्तो हुन आयो। त्यस्तो अवस्थामा हेर्नुस् त fx2 चाहिँ fx1 भन्दा के हुने भयो त दैट्स ग्रेटर हुने भयो, त्यसकारणले fx1 चाहिँ ग्रेटर छ fx2 चाहिँ स्मलर छ, which shows x increases y or y भनेको के हो त fx हो, y or fx decreases. Thus y is equals to fx is a decreasing function is a decreasing function if dy by dx is equals to f dash x, which is less than 0. This is the definition of decreasing function. I think you don't have any confusion here. The most important part is here. Just we wrote these all in language. Now let us study about the maxima and minima of the function. So maxima and minima of a function. For this one, let us look one diagram. Again, we are going to observe this one curve line on the first quadrant. Let us take one point somewhere here. We can draw one perpendicular line. We draw from here to here one perpendicular line. Similarly, from here suppose this one is here, this one we say this one is C, point C, and this point is C minus H. Again, taking another one point, and suppose this one is C plus H. Then we have this one, this line, this is Y, and then this one is X, and this curve name is Y is equal to Fx, and this one is f of C, we can write, and this one also we can write f of C minus H, and this one is we can write f of C plus H, and this one is O. So let's write the definition of maxima and minima of the function. A function fx is said to be maximum at x is equals to C. Here is C. So maximum at x is equal to C. If fc is greater than f of C plus H, here is fc, this one is fc is greater than f of C plus H भन्दा fc ठुलो छ हेर्नुस् त, or we can write or fc greater than fc plus H for small positive value of H. For small positive, here is very small positive value of H here. यसको डिफरेन्स हेर्नुस् त, H को डिफरेन्स छ. Similarly, a function fx is said to be minimum at x is equal to C if fc is less than f of C plus H. हेर्नुस् त यहाँ fc is less than fc plus H. fc is less than FC is less than FC minus H. C minus H. हेर्नुस् त C minus H FC भन्दा स्मल छ. यो हाम्रो FC plus C plus H नै हो. अब हेरौँ त C plus H, or we can write or FC is less than F of C plus H for small positive value of H. Now let us discuss about the point of inflection. Point of inflection. A point X is equal to C is called the point of inflection if first dy by dx is equals to first derivative is equal to 0, or we can write for the first derivative f dash x is equals to 0 at x is equals to c. Second, that one is f double dash x is equals to, this means d square y by dx square. This one is second derivative is equals to 0 at x is equal to c. And the third one is f triple dash. This one is third derivative, or d cube y by dx cube. This is third order derivative for you, which is not equals to 0. यो त भयो point of inflection को बारेमा. अब हामी criteria for maxima and minima को बारेमा चर्चा गर्दै छौं. Criteria for maxima and minima of a function at a point. For this one, we need at first condition, then after maxima, then minima, and then no maxima or no minima. अब हेरौँ है त हामी फर्स्ट अर्डर डेरिभेटिभमा सबभन्दा पहिला हामी हेर्छौं फर्स्ट अर्डर के हुन्छ त हामी के हुन्छ मात्रै हामी हेर्दै छौं. यहाँ फर्स्ट अर्डर डेरिभेटिभ भन्ने बित्तिकै dy by dx we write f dash x and this is equals to 0 for maxima, and then similarly dy by dx is equal to f dash x is equals to also 0, and then here dy by dx is equals to f dash x also is equal to 0 for all three cases. Let's close it. Now for the second order derivative मा अब हेर्नुस् है त फर्स्ट अर्डरमा फाइन्ड आउट नभएको सेकेन्ड अर्डरमा हुन्छ. जस्तै सेकेन्ड अर्डर भन्ने बित्तिकै d स्क्वायर y by dx स्क्वायर भन्ने बुझाउँछ. यो भनेको f डबल ड्याश x हो. this is less than 0 for maxima, and then d square y by dx square is equals to f double dash x, this is second derivative, is greater than 0 for minima, and then d square y by dx square is equals to f double dash x is equals to 0 here. Now third order derivative. In this case, for maxima and minima not there, so d cube y, this is third order derivative, or dx cube, it means f triple dash x, which is not equals to 0. So in this way we calculate the maxima, minima, or no maxima and minima. Now concavity र convexity को बारेमा हामी अहिले हेर्दै छौं. Concavity and convexity of curve. The graph of the function y is equal to fx will be concave upward or concave downward according as d square y by dx square, यो भनेको second derivative हो, is greater than 0, or d square y by dx square is equals to f double dash x less than 0. Now we are going to solve certain problem of this exercise, and here problems. Question number 1. Examine whether the function fx is equals to 15x square. Suppose one example we can take minus 14x plus 1 is increasing or decreasing. At x is equals to 2 by 5 and x is equal to 5 by 2. यसको solution हेरौं हामी. Here fx is equals to 15x square minus 14x plus 1 is the given condition. So f dash x is first derivative. We can write 15 times to 30x minus 14. At x is equals to 2 by 5. X is equal to 2 by 5. F dash x कति हुन्छ हेर्नुस् त. Here 30 times 2 by 5. 30x भनेर ठाउँमा 2 by 5 minus 14. Here 5 6 times, and this is equals to minus 2, which is less than 0. Again at x is equals to 5 by 2, f dash x is equals to 5 by 2 राख्दा कति हुन्छ त. अब हेर्नुस् है त, 30 times 5 by 2 minus 14 is equals to this 15. 75 minus 14 is 61, which is greater than 0. Therefore fx is increasing at x is equals to कति मा रहेछ त fx को increasing हेर्नुस् त fx को increasing 5/2 मा रहेछ 5/2 because this one is greater than 0. In this way we can solve this question.